All right, here we are. We've got, I'll tell you what, I apologize for the sketchy, for the bad cartoon here, but to spend 5 minutes doing that beats the heck out of spending 3 hours on Creative Commons looking for two football players running at each other. I'll just throw that out. So there we go, and you're gonna get the same idea anyway. Oh, this guy's naked. Let's put some pants. Oh, and he's not wearing pants. Let's put some pants on both of them. All right, and put a shirt on him, some sort. There we go. All right, now they're not naked. Okay, so this is the initial setup. You got this guy running with the football, going this way, positive 8 meters per second this way. This guy coming at him this way. Boom! They're going to hit right here. Boom. All right? And they're going to stick together. They're going to stick together. And then we'll look at the situation in the next little video. We'll look at a situation where we've got maybe two objects that bounce off of each other. Right, like two hockey players bounce off of each other. All right, so they stick together. So here's what happens. So they're going to stick together here, and we've got so the momentum before, the entire momentum before is equal to the momentum after, and we're going to calculate to see if and this was an actual collision. We're going to see if the kinetic energy is conserved, because when they stick together, it is an inelastic. That is about as inelastic as that's a completely inelastic collision. Most collisions are partially inelastic. Like if you have a little fender bender, you kind of bounce off the other car. Your car crumples, loses a lot of energy in that deformation. His or her car crumples, headlight breaks, lots of energy loss there, even some mass loss now because you. So anyway. But we're going to look at this situation. So let me scoot this up real quick. Now we can leave it down here since I'm running out of table to write on. So we've got mass of player one. Let's just call him mass one and V naught one. We don't need to put the player in there. Mass one times V naught one plus mass two times V naught two is equal to. They stick together. I want to find the final velocity after when they're done. That's what we're after. What is their final velocity after they stick together? So we've got m1 plus m2 times the final velocity. Oh, look at that. That's going to be nice. That's going to be nice. Now, see, in the next one, I'm going to have to kind of come up with, kind of like our ice skaters, I'm going to have to come up with a velocity of one of them so that we can figure out what the velocity of the other one is. All right, so anyway, so we've got this. So let's go ahead and work that problem.